So before we go on to the next problem, I did just want to put up this last one with the GPAs on the screen in case anybody missed something and needs to copy it. We have our correlation coefficient in the equation of our line. And then our next problem is actually really interesting. This one is a company, and what they're doing is they're comparing the commuting distance, so how far people live from where they work, and then the number of absences they have. So they're looking to see if there's some sort of relationship there, and if so, if it's linear. So you're going to go through, find the correlation coefficient, the least squares line, and answer a couple of questions, kind of put together a lot of the skills that we've looked at in section 1.6. So I'd love for you to pop over to Excel, copy that data into Desmos, and then pause the video and give this a try. All right, so hopefully you gave that a try. Let me switch over to Desmos so we can take a look at the graph. All right, so here we are in Desmos. You can see I've copied the table over here on the left. And as I look at this scatter plot, it does look pretty strong. It's a little bit scattered, but really not too bad. So I would think that this is going to be a pretty reasonable correlation coefficient. So when we come back over to the left, we look, and sure enough, our R value here is 0.7673. So that is getting closer to +1 since this is a positive graph. We're looking for the stronger numbers to be closer to +1 rather than -1. So we do have a reasonable correlation coefficient. It does look pretty straight. So this equation is a good plan. And I'm going to go ahead and use 2 decimal places for this. If you used 1 or you used 3, you'll get answers that are really pretty close to mine, but they'll just be slightly different. And as far as the homework and stuff goes, I'm going to write the keys so there's some flexibility in there based on how you round. But if you have any questions about the grading, if you think that maybe your answer is right, but because of how you rounded it just ended up looking further away, definitely reach out to me. I'm happy to take a look at that and kind of let you know what's going on. All right, so our equation, we have an m. I'm going to round 2 decimal places, so I get 0.19 for the slope. And then my correlation coefficient, or my intercept is positive here, so I'll have a plus. Then 2 decimal places here gets me 2.24. All right, so we have our correlation coefficient in our equation. So let's switch back over to our notes. Okay, here are our notes, and you can see that I've brought over our numbers from when we were in Desmos. Our next question here is a prediction question. So it says, how many absences can we expect from an employee who lives 13 miles from work? So what they're asking us to do is to take this 13 and substitute it in for x. So I'll get y is equal to 0.19 times 13 plus 2.24. And when I crunch that in the calculator, I get about 4.71, so almost 5 absences here if I were to round up to a whole number. So I'm going to leave it as 4.71, but kind of in our heads, we're thinking, that probably means they're going to be gone about 5 times. All right, so there is our 13-mile-away employee. So let's take a look at what values would be reasonable to plug in. 13 is definitely within our point set, but let's look for our smallest x values. So our x's are in this top row here. It looks like my smallest x is a 2. And then if I'm looking for my largest one, that's a 21. So I would say in general, probably if you go anywhere between 2 and 21 miles away, this should give us fairly reasonable predictions. Maybe 1 to 22, a little bit outside of that would be fine as well, but not too terribly much beyond that. All right, and then we have 2 interpretation questions. This is for the slope and the intercept. So again, this is something we looked at in 1.4. We practiced again at the beginning of 1.6. So let's give this another try. So our slope, as our x value increases, so we're looking at our commuting, as the commute increases by 1 mile, absences increase by 0.19. Okay, so every mile further you live away from work, the number of absences you take increases by about 0.2. Okay. And then our intercept. So our intercept is that fixed value that sits on that y-axis or vertical axis. So that happens when our x value is 0. So that would be our commute. So I could say something like a person who has a commute of 0 miles. I could say when the commute is 0 miles, any of those kinds of things would work. You miss 2.24 days of work. Or you could say 2.24 days of work is missed, kind of anything along those lines that gets at this flavor. All right, so hopefully that's a nice little review of kind of what we've covered in 1.6, as well as a little bit from like 1.3 and 1.4. You will see a problem on the homework. I think it's the last one on there that kind of asks you to go through this whole process again, which will be a really good review for you before the exam. All right, come back in the next video. We'll kind of tie together all of the loose pieces from this least squares regression, and we'll wrap up 1.6.